So yesterday we started with that formula derivation because I didn't have this all set up, and I knew that would take me some time to get set up. And then we had the great textbook interruption, so that was kind of a waste. So we probably will restart the formula derivation in the next day or so. So I would like to do this because this sort of ties in with what we're doing. One last sort of look at graphs, okay? And I think what I'll do is, because they're starting to look for, do we have marks up on Edline or not? There's 10 multiple choice questions at the end. It'll be nice and easy for me to mark, and you'll all get 10 out of 10, and then everyone will be happy. So, what I would like you to do is make some predictions. So it says, in this lab, we'll be rolling a cart up and down a ramp, creating DT, VT, and AT graphs that correspond to the movement. So first of all, I'd like you to make some predictions. So all of page 1 there are strictly predictions. Okay? So draw a sketch of what you think a DT, VT, and AT graph look like for a cart rolling down a ramp. So what I'm going to do is I'm going to get a book. Maybe I'll borrow Justin's and Matt's here. And I'm going to build a ramp here. Can I borrow yours, Justin?
Please.
Oh, watch.
Oh, please.
Please. Please. Where is it? Okay, so we're going to roll. Oh, I see. Okay. We're going to roll the cart down the ramp. Okay, so I would like you to make a prediction for what it would look like. All right, so while that's loading up, I'd like you guys to make those predictions. Now, I want you to do that. Don't be one of those people who are, oh, I'll just wait to get the right answer. Because the right answer comes later. So I'm not going on until I see everybody with 9 predictive graphs on that front page. Okay? Don't give me that, Watts. Any others that you want to?
There's one on the top row.
This one? You want to move it up now? Okay. Calvin wants to move his up.
I did it too.
Okay.
What question, man?
You think it's above like this? Okay. Anything else? All right. Well, let's see what happens. Okay. All right. So I'm going to go to the second page now, Chris. Okay. Justin, do you want to be my my computer assistant, or do you want to play with the cart?
How do I do the computer system?
Well, just click, and or do you want to just do the cart thing?
No.
You come do the cart thing. No? Because I can't do both. All you gotta do is like push the cart up the hill.
Okay.
Easy.
I do it from right there?
You can reach.
No.
Come around here.
Here.
Oh, for crying. All right. So it says, number 4, use the Science Workshop apparatus to determine the actual graph. So we're going down around. Actually, all you do this one is release, right? Yep. Okay. And make sure when you release, pull your hand out of the way. Okay. Okay. You want your paper so you can just drop them there?
Yep.
All right. So Justin's going to let it go, and we're going to go down the ramp. Graph number 1 is position here. Okay. When you hear the clicks, go ahead.
Can you stop it?
No. It's called a crash cart. It's okay. All right. So here's our graph, and what I'm really interested in is really just which part of the. Oops. I'm really not interested in that bit there, right after the crash. So what does it look like? The curve, right? Is that what you had? It's a curve. There's a little glitch here. I'm not sure what's going on there, but for the most part, it's a curve. Is that what we predicted? Uh-oh. Uh-oh. Not right, right? What is it? What is it? I told you not to erase. And remember, this is on page 2, right? Page 2. Draw the actual. Do not erase your predictions. You'll learn from the prediction. Okay, so it's actually curved like that. How come it's like that? Well, because it's moving to the right, so the displacement is actually positive or negative. Positive. To the right is positive. When we had our prediction, that's negative displacement. Okay? Just because it's down the hill doesn't mean it's negative, right? To the right. means. Okay, so now I got to go to the velocity time graph. Let me see if I can find it here. This one's the velocity right here. And what does it look like? Well, let me just zoom in a little bit here. What's that really representing? Yeah. Okay. Without that little glitch in here, the first 0.8 seconds there, that's just Justin's reaction time, right? And then it goes like that, doesn't it? Right? Okay. And that's exactly what you would expect. That's exactly what you would expect. Go away. Okay? It should be straight line like that. Right? Increasing speed, increasing velocity. What did we predict? Someone predicted negative velocity because it's down the hill. No. So now, what do you think here about Kelvin's? The black one or the red one?
Red.
The red one now? AT graph is this one here. Oh, no, it's not. Graph number 3. Ooh, tough to say from there, isn't it? Hang on a second. The acceleration is to the right, and to the right is positive. So you're right, Mark. It should be positive. Okay, so Kelvin made a quick change there, and the red one is correct. Okay, positive acceleration. Okay, now I didn't ask you to predict this, but now what I'm going to get you to think about it, if it's at a greater incline, I'm just going to grab a couple more textbooks here. And borrow yours, please. Maybe yours for those under there. And what do you think? How is that going to change the graph by making it steeper?
It'll make the move sharper.
Will be a steeper curve, you think? You've got the curve there, Justin?
Yeah.
Okay. All right, I'm going to... Eh? No, we'll let it crash. That's more fun. Okay, so when you hear the tick marks. Are you scared? Okay, so just as I think it was Hunter predicted, we've got a much steeper curve here, right? What about our velocity? Is it a steeper slope? Yes, in fact, actually we got a nice one that time, didn't we? We didn't get any little glitches. What's all this happening here? Crash. And the acceleration, let's just see what the acceleration looks like. What should it look like, do you think? Should it be flat again?
Yeah.
But where? Higher up. Let's just see if I can zoom in here. The acceleration, what it's doing actually, it's actually doing some calculus. So all of it is calculated. Yeah.
Nothing changed.
Not the best, right? Yeah. And you really need an accelerometer, which I do have, but it takes a little bit longer to set up. Kind of. So what should it look like under there, under your, on your drawings there? Steeper incline, what should it be like? That, and higher up, right?
Mm-hmm.
Right? Okay. Oh no, you guys don't actually have a spot for that, do you? You could just draw it on the top of there. Number 6, what mistakes did you make? Write in your own words a way to remember what the graphs look like. So I'll give you 30 seconds. Look back at your prediction, see how you did. Write a little note to yourself what you did wrong. Learn from your mistake. All right. So we're going up the ramp now. Let me just get rid of these guys here, this data. And we're going to go to graph number 1. Okay, when you hear the clicks. Oh, I sort of gave it away a little bit. Is that a good one, do you think? Is that a good one? That looks pretty good, right? Okay, so once again, we got a flat part there. Apparently, Justin's reaction time has gotten slightly better. It's good, right? A little over half a second. And what's happening to the position time graph? First of all, why is it starting way up here at 2? Like, how come the graph starts way out there?
Is that the starting point from 0?
Where's the origin? Where's 0?
The black box.
Yeah, right here, right? The sonar thing, the black box thing. That's 0, so it's starting like 2 meters away. To the right, positive. So it's starting way out there. You could ignore that, but then what you should be drawing is that bit right there, right? Ignore that part. So up the ramp, we would have, what did it do? It was like this, right? Was it like that? Is that what we predicted?
No.
It's close though, isn't it? What's wrong with this one? Where does this one start? 0. And what's the slope here? Is it positive or negative? The slope here is positive and it goes to 0. So the going to 0 is right, but in fact this time the velocity is which way?
Negative to the left.
Negative to the left, right? So the slope has to be down. Good thing I went over this. So yeah, negative slope going down to 0. All right, now I don't know if you saw the velocity time graph here. Let me just see if I can find it. Graph number 2, there it is there. Now you can ignore this part right here. I wish I'd stopped it earlier. Okay, what's happening for the first 0.6 seconds? Justin's brain is processing to push, right? And then what's happening here? He's actually pushing, right? He's actually pushing, so the velocity is increasing negatively, and then once he lets go, what does the velocity do? It goes to 0, right? When does it go to 0? Right there. That's a good one. Okay, so what should I be drawing? I should be drawing negative velocity going to 0. Is that what we predicted? I don't think so. What's the acceleration graph going to look like here? Once again, we may not get very nice picture. Where is it? Nope. Nope. There it is there. Ooh, that one's a good one. Hey? Zoom in, come on. What's happening? It is clearly what? What's happening for the first half a second? Nothing. Then what's happening here? He's pushing, and then once he lets go, whoops, what's happening to the acceleration? Positive and flat. What's going on? Is the acceleration positive? The velocity is up the ramp negatively. Which way is it slowing down? This way. Which way is the acceleration? The gravity is pulling it this way, right? Positive acceleration, positive and flat. In fact, is that not just exactly the same as before? Right? Positive slope, right? Positive constant slope, flat. Throw this book back in there again, Justin. Okay, we'll try it a little steeper here now. All right, so what do we get?
Steeper.
Steeper. How come? How come it goes like farther down here?
Because it got closer to the black box.
Because he pushed it harder and he was a little better the second time, right? He had a little more practice, right? So he got it closer to the black box. If could he push it to get to there? Like does this really mean anything? The fact that they're separated? All it means is what? he pushed relatively harder and got closer to the black box. Okay, and it looks like your reaction time is a little bit slower this time. Okay, so same kind of thing, right? Steeper there. What about the velocity time? No. This one. The velocity time is the purple one. So it's in fact what? Why is it steeper? What's the acceleration like on this one? Is it greater acceleration? Greater deceleration? Should be, right? Because it's doing what? Slowing down faster. Slowing down faster because it's steeper. So there's your velocity time graph, and the acceleration time graph should be, let me see if I can find it. There it is there, right? The red one is slightly above. Okay, so if you were to draw those, it would be, right, much steeper, steeper, and higher up. Okay, same thing, Justin, except we're not gonna stop it at the top. We're gonna let it roll back down. Okay, you want to take those books out? If you thought about these when you're doing the prediction, you would realize that really you just have to take the two graphs and do what? Put them together. Put them together. Okay. Do you want another practice here?
No.
You good? Okay. Ready?
Oh boy. It's pretty good.
It is pretty good. Do you want to leave it? Okay. All right. Is that what you thought? Why does it do that? Well, again, here's the reaction time. He's starting at 2 because it's here, right? It's going to the left, so the slope is negative. It only goes about halfway, because Justin didn't push very good, right? Does it ever stop? Does it ever go to 0, the velocity? The velocity goes to 0, right? Right there. It flattens off, and then it speeds up as it comes back up the hill. Or comes back down the hill, sorry. So you get that bowl sort of shape, right? So yeah, you should have up, down, should be like that. The velocity time graph, what do you think? Let's see if I can find it. Is that correct? Absolutely. Here's the pushing phase right here, right? And then as it goes up the ramp, the velocity goes to 0. Don't you dare erase your predictions. Goes to 0, and then what's happening here? It's speeding up, right? It's speeding up. Chris, what would you say about the slope of this line? Is it constant? Seems to be. Let's have a look at the acceleration. Flat and positive the entire trip. Flat and positive the entire trip. Want to throw those 3 more books in there? Push. Okay, so what do we got here? Much steeper, like a parabola, right? With a higher numerical coefficient. Much steeper. This time you pushed it better and it went closer. But the shape of all of them should be the same. Steeper here because it's faster. Steeper slope because the acceleration is higher. In all of the cases, what did the acceleration graph look like?
Constant.
Constant, flat. Every single one was like that for the entire trip. How come? Which way is the acceleration? Down the ramp. The acceleration is down the ramp, whether it's going up the ramp, down the ramp. I guess that's what it's supposed to do. Right? The acceleration is down the ramp. Okay. All right. Part D here I haven't deleted out yet. It was really confusing, so what I did was I turned it into multiple choice, okay? So I would like you to take the rest of the time here to work out, go through those multiple choice ones and make your selection, okay?